Hi Nesreen, and thanks for the question. This limit hinges on two parts. The first is, how are we going to handle the absolute value? And secondly, what can we do when we plug in 3 into both the numerator and denominator and get 0 over 0? For the absolute value, we have to remember that piece of Algebra 2 that you learned on the first day and didn't pay too much attention to. And that is the definition of the absolute value, which says the absolute value of A equals A if A is greater than 0. That's the simple part. But then the part that we always forget is that if A is less than 0, then the absolute value of A equals negative A. Knowing that, we really have two limits to compute here. We're going to have the case for A being greater than 0 and the case for A being less than 0. So let's write that out. So our first limit for the case of A being greater than 0 is the limit as x approaches 3 of the positive absolute value. So x squared minus 5x plus 6, and nothing changes with the denominator, it just stays x minus 3. But for the case when A is less than 0, we have to take that into account by saying the limit as x approaches 3 of the negative A, so which gives us the negative x squared minus 5x plus 6. And again, nothing changes with the denominator. Remembering what I'm calling the useful fact in the top right, that the limit as x approaches A of a function equals L if and only if the limit from the left equals L and the limit from the right equals L. That means for us, these two limits must be equal. If they're not, our parent limit does not exist. So that's what we're really solving for here. So this takes care of our first hinge. But what about our second, where we plug in 3 into both of these and get 0 over 0? For this, we'll use the always useful L'Hopital's rule, which says that we can take the derivative of the numerator and the denominator independently and then take the limit of what results. So let's see what that gives us. When we take the limit, we'll start with the left side as x approaches 3, and the derivative of the numerator is going to be 2x minus 5, and denominator is just 1. Now we can plug 3 into this, and that gives us 2 times 3, which is 6, minus 5, which is 1. So that's going to give us 1 over 1, which is 1. What about this right-hand limit? We have the same 0 over 0 case. So taking the derivative of the numerator first, we get negative 2x plus 5 over 1. We can plug 3 into this now, get negative 2 times 3, which is negative 6, plus 5, that gives us negative 1 over 1, which is negative 1. But what you see is these two limits do not equal one another. That means the limit of our parent function does not exist. Thanks for the question. I can't wait to see the next one.